Hello everyone, it's a pleasure meeting you again in my mathematics class. Today let me solve the given differential equation y double dash minus y dash minus 2y is equal to sine 3x, not by ordinary method but by using Laplace transform. And we have to solve this with the initial condition that y of 0 is equal to 0, 1, y of 0 is equal to 1 and y dash of x is equal to minus 1. See that? So let me apply. See, let me take given, say right here, given y dash, y double dash minus y dash minus 2y is equal to sine 3x. So your y dash is equal to your dy by dx and y double dash is equal to d squared y by dx squared. This is the meaning of that. Now, let me apply. See, now apply Laplace transform on both sides of 1. Call this as your 1 and this is your Laplace transform. Apply Laplace transform on this. So you get what? L y double dash minus L of y dash minus 2 into L of y is equal to sine 3x. So I apply the Laplace transform on this, and when you apply Laplace transform on the left hand side using the linearity property of Laplace transform, it becomes L of y double dash minus L of y dash minus 2. You can take the constants also outside in the case of Laplace transform. So 2 into L of y is equal to L of sine 3x. Now I will give you the value of this by working out, because I explained to you how you should get the value of the second derivative of a function, Laplace transform of a second derivative function, and also first derivative, and also value of this. See? See, L of y dash, this is the function of x. This is nothing but definition of Laplace transform. It is e to the 0 to infinity, e to the power of minus sx into y dash of x into x by definition. By definition of Laplace transform. So this is what we have. Now, therefore, this what you can write in this is, so this is equal to, I'll write it here. See, L of y of x is equal to 0 to infinity of e to the power of minus sx into y of x dx. This is the definition of the Laplace transform. So I'll write this as 0 to infinity of e to the power of minus sx. This is nothing but dy by dx into dx, which is nothing but, so this is nothing but your 0 to infinity of, it is 0 to infinity of e to the power of minus sx into d of yx, into d of x. Now using Bernoulli's method of integration, I can write this as it is e to the power of minus sx into y of x. It is 0 to infinity minus integral of, differentiate this e to the power of minus sx, so you will get it as what? Minus s into minus sx into integral of y of x into dx. So this is equal to, when you apply the limits, it is e to the power of infinity is 0. So e to the power of minus infinity is 0. So if you apply the second limit, it becomes minus y of 0 minus, if you apply that is minus into minus, you make it as plus. It is s of e to the power of minus sx into y of x dx. This is nothing but minus y of 0 plus s into L of y of x. See, L of y of x is equal to this value. Therefore, this is equal to. So, I can write therefore L of y dash of x is equal to, it is nothing but s into, it is L of y of x minus y of 0. Call this as equal. So, I am able to get the value of the integral value of this L of y dash Laplace transform of the derivative. Now, see, now L of y double dash is equal to, so I can write this using the Laplace definition of Laplace transform. It is 0 to infinity of e to the power of minus sx. I can write this as, see, y double dash of y double dash into dx. This is nothing but your 0 to infinity. It is e to the power of minus sx divided by dx into y dash into dx, that is equal to, so this is nothing but your 0 to infinity e to the power of minus sx into d of y dash. So d of y dash, so you can use the Bernoulli's method of integration again. So it becomes e to the power of minus sx into y dash of x. It is 0 to infinity minus, it is integral of s minus s into e to the power of minus sx into this one. See, you have to integrate this y dash of x into dx. Now again, if you apply the limits here, this will become as what? It is infinity. This is infinity means e to the power of minus infinity is 0. If you apply that is 0, it is y. Because e to the power of 0 is 1, y dash of 0. Minus into minus is plus, yes, integral of 0 to infinity e to the power of minus sx into y dash of x into dx. Now this is nothing but what? Your, see, using 1, the value of this integral, this is nothing but what? S of this, see, e to the power of minus sx, see, this is what we have got here, y dash of x. E to the power of minus sx, y dash of x, that is nothing but what? L y dash. So I can write in this place minus y dash of 0 plus s into, this is nothing but your L of y dash. But that is equal to minus y dash of 0 s into, see, using a, you have got the value of this. So it is minus y of 0 plus s into L of y of x. So this is equal to, so when you remove the brackets, s into s is s square into L of y of x minus, see, plus into minus will be minus, s into y0 minus y dash of 0. Call this as 0. So this is your L of y double dash. So L of y double dash has been gone. So I am able to derive L of y dash, which is equal to so much, L of y double dash is equal to so much. And now I will write here e to the power of, see, e to the L of e to the power of ix is equal to Laplace transform of e to the power of ix is equal to, this is nothing but L of cos x plus I sin x. And you must know that this is equal to, because linearity property holds good in the case of a Laplace transform, this is nothing but what? L of cos. I can put even, I will put here as ax. Here then you will get it as cos of ax, and this is sin of ax. And this is cos of ax plus I, because you can take this I sin, I can be taken outside, I L of sin ax. Now this is equal to, as per the definition of Laplace transform, this is 0 to infinity e to the power of minus sx into e to the power of, here, iex into dx. So this is equal to, Here it is 0 to infinity. It is e to the power of minus s minus ia into x into dx. The integration is very simple, that you get it as e to the power of minus s minus ia of x divided by minus s minus ia, and the limits are from 0 to infinity. So when you apply the limit infinity in the place of x, e to the power of minus infinity is 0. Then minus, if you apply the second limit, this simply becomes 1 by s minus a. Now multiply this by s plus conjugate, s plus a, divided by r plus a. So this is equal to your s plus, so I write it here, s by s square plus a square plus I into a by a square plus a square. So you see that the Laplace transform of L e to the power of IAX, which is equal to this, is equal to nothing but s by a square plus a square plus I into, equating all and imaginary parts. Real and imaginary parts, we get L of cos Ax is equal to, it is s by s square plus a square, which implies cos Ax is equal to L minus 1 of s by a square plus a square, and L of sine Ax is equal to a by s square plus a square, which implies sine Ax is equal to L minus 1 of a by x square plus h square. Inverse Laplace transform. So this is what we get. So this is how we work out the Laplace transform of a first derivative and of a function, and this is the Laplace transform of second derivative of a function, and this is nothing but how we find the Laplace transform of sine Ax and cos Ax, and that the inverse Laplace transform over this. For your kind small information, know that it is see, if L of, it is e to the power of Ax is equal to, the value if you find, it is nothing but 1 by s minus a. Therefore, you will get this e to the power of Ax is equal to inverse of Laplace transform of s minus a. This is fine. So Laplace transform of e to the power of Ax is 1 by s minus a. Therefore, e to the power of Ax is equal to inverse transform of this. So I will work out the problem using these ideas. So let me start working out this. So what is that we will get here? Y double dash, in the place of y double dash, we can write s square. See it is, that is s square into L of y minus, say s square, it is s into, it is y of 0 minus y dash of 0 minus, it is s of L of y minus y of 0 minus 2 into L of y is equal to, I will write this as 3 divided by, it is s square plus 9. So we have got this. See, so the Laplace transform of Ly double dash is s square L of y minus s y of 0 minus y dash of 0 minus Laplace transform of this is s of L of y minus y of 0 minus 2 times of L of y is equal to Laplace transform of 9 3x. This is now substituting. Now you substitute the value here, that is s square. See, I will take this L of y outside into s square. Here one L of y is here, s square minus 2. Then minus s into y naught minus y naught of 0. Then minus into minus is plus, plus y of 0 is equal to 3 by a square plus 9. So that is Ly into a square minus s minus 2 minus. Now you see that this is s of y naught. Y naught value is 1. So minus s. Minus into minus is plus 1. And this is y naught value is 1. So this is equal to 3 by a square plus 9. So this implies L of y a square minus s minus 2 is equal to 3 by a square plus 9. And then it is plus s minus 2. S minus 2. So what is that you get? Therefore you get, so L of y, this is nothing but s plus 1 into s minus 2. If you factorize this, you get s plus 1 into s minus 2, s square plus this is equal to 3 divided by s square plus 9 plus s minus 2. So this simply implies you get L of y is equal to 3 divided by s square plus 9 into s square plus 9 into, it is s plus 1 into s minus 2 plus s minus 2 divided by s plus 1 into s minus 2. So this implies L of y is equal to 3 divided by s square plus 9 s plus 1 s minus 2 plus 1 divided by s plus 1. Now you see that I am able to get the value of this L of y. If I will simplify this using partial fractions, then apply the inverse Laplace transform to get the answer. So that is the technique that I am using. What I am going to do is, I will factorize this, split it into small fractions, and then apply the inverse Laplace transform so that you will get the value of y of x. Now, see, I will remove this. See, what is that we get here? That is, now, see what I will do here is, I will take only, this is a small fraction that I will not disturb. I will take only this and split it into small fractions so that I can just add afterwards with this and get the answer. Now, say right here, now let 3 by s square plus 9 into s plus 1 into s minus 2 be equal to as plus b divided by s square plus 9 plus c divided by s plus 1 plus d divided by s minus 2. Let us have it in this way. D. See, now what we have to do is, we have to get the value of the constant ABCD. Here we see that I have put as plus b because in the denominator you have got a quadratic expression, therefore you must put as plus bd. Now, if you put, see in this we have to get the value of ABCD. Put s is equal to 0. So when you put s is equal to 0, what that you will get is, when you put s is equal to 0, you will get See, 2b minus 18c plus 9d is equal to 0. When you put s is equal to 0, so this, see, this one, this implies, I'll write here, as plus b into s plus 1 into s minus 2 plus c into s squared plus 9 into s minus 2 plus d into s squared plus 9 into s plus 1 is equal to 3. Put s is equal to 0 in 2. So when you put s is equal to 0 in 2, you see that this will become 0, this will become 0, this will become 0. It is minus 2b. And this will become 0, and this will become, this is minus 18. And this becomes 0, so you take 90. And you put s is equal to 1. So when you put n is equal to minus 1, so when you put s is equal to minus 1, this will vanish and this will vanish, and you are given the value of minus 30c is equal to, see, is equal to 3, which implies c is equal to minus 1 by 10. Then put s is equal to 2. Put s is equal to 2, you will get the value of this to be 39d, which implies d is equal to 1 by 30. You get d is equal to 1 by 30. Now substitute, see, I'll call this as your a, b, c. Substituting in a, we get, substitute the values of this in 1, this in a, substituting b and c. Substituting b and c in 1, we get the value of b. The value of b, you will get it to be minus 33 by 65. So these are the values we get. Now you see that I am able to get the value of c, I am able to get the value of d, and I am able to get the value of b. To get a, we get a. Equate the coefficient of s cubed on both sides. So what is that you will get? Here there is no c, it is a, it is c plus d is equal to 0. Now what is that? A, it is minus 1 by 10 plus 1 by 30 is equal to 0. So if you solve this, you will get the value to be a is equal to 3 by 130. So this implies a is equal to 3 by 130. So these are the values that you get. So I write it here. So what is the value that you get? A is equal to, you get the value of a is equal to 3 by 130. B is equal to 30 minus 33 by 130. C is equal to minus 1 by 10, and D is equal to 1 by 30. These are the values that you get. A is equal to 3 over 3 by 130, B is equal to minus 33 by 130, C is equal to minus 1 by 10, D is equal to 1 by 30. So substituting here, what is that you will get? Therefore we get, see, L of y is equal to, it is 3 by 130 of, it is AS plus B is minus 33 by 30, 33 by 130, AS plus B divided by AS squared plus 9 plus C is minus 1 by 10 of 1 by S plus 1, then D is plus 1 by 30 of 1 by S minus 2. plus we have this 1 by s minus 1. So we have this s minus 1. So therefore L of y is equal to 3 by 130 of s by s squared plus 9 minus 33 by 130 into 1 by s squared plus 9 then see this is minus 1 by 10, this is plus 1, therefore it is plus 9 by 10 divided by s minus 1 plus 1 by 13 of 1 by s minus 2. So this is what we get. Now you see that here if you want y, what is the value of y of x? It is equal to 3 by 130 L minus 1, because L minus 1 of this sum is equal to sum of the L minus 1. Inverse Laplace transform of a sum is equal to sum of the inverse Laplace transform. So here this L minus 1 of this will be equal to, see, it is like this. It is L minus 1 of right hand side. So that is equal to 3 by 130 L minus 1 of L by L square, s by s square 9. Then minus 33 by 130, then it is my L minus 1 of, it is L minus 1 of 1 by s square plus 9, then plus 9 by 10 L minus 1 of 1 minus s minus 1. Then plus 1 by 13 of L minus 1 of s minus 2. S minus 2. Now you see that is L of y. That is L of y is equal to, see, 3 by, see, L minus 1 of this, see, I will show you that, see, L minus 1 of s by s squared plus 9, see, here I have written here, see, L minus 1 of s by s squared plus 9 squared is nothing but your cos ax. In the place of this thing, a you have got 3, therefore it is cos 3x. Say refer to this, you will understand. So this is nothing but your cos 3x. Then minus 33 by 130, and you see that L square, see here you can find sine. You can see this L of sine ax is equal to a by a square plus a square. Therefore the inverse Laplace transform is nothing but L minus no a divided by a square plus a square. So the sine ax is equal to L minus 1 of a by sine square plus a square. You can find that here, this one you can find, see here you find that it is merely 1 by a square plus a square plus 9. So that 3 is missing. So what you have to do is minus L minus, see what you have to do here is multiply this by 3 and divide it by 3. So it is L minus 1 of 3 divided by a square plus 9. Now you write like this, and this is plus 9 by 10 into, see, the inverse Laplace transform of minus 1 I have written here. See, inverse Laplace transform of, it is L of e to the power of ax is e to the power of ax is equal to 1 by s minus a. Therefore the inverse Laplace transform is e to the power of ax. And likewise L of, see, L of e to the power of minus ax is equal to 1 by s plus a, which implies L minus 1 of 1 by s plus a is equal to e to the power of minus ax. So if it is plus, it is minus. Okay. Now you see that applying this idea, here you get that this is nothing but, see, this is nothing but 9 by 10 into, it is e to the power of, it is minus means it is 1 of x, plus it is 1 by 13, it is, actually this is plus 1, this is plus 1, this is plus 1. So this is s plus 1. So this is s plus 1 means this is minus. And this is 1 by 13. This is L minus 1 by s minus 2. So this is nothing but e to the power of 2x. When it is minus, you put plus. So if it is plus, it is minus. So this is what you have as the inverse Laplace transform. So this is nothing but what? 3 by 130 cos 3x minus 33 by 130. See, 1 by 3 means this becomes 11. 11 by 130 into what is this? This is nothing but sine of, see, it is sine 3x, and this is nothing but plus 9 by 10 into e to the power of minus x plus 1 by 30 into e to the power of 2x. So this is your solution for this L minus c. This is y of x. This is y of x is the L minus 1 of this. So this is the answer. See, if you solve the ordinary differential equations, I will solve in the next class how we are getting this solution using ordinary differential equation. Okay, so this is how we. So the important thing is I have fully worked out your L of y dash, L of y double dash, and also the how to get the value of L of sine 3x, sine x, sine ax, and cos ax, and also the concept of inverse Laplace transform, and also L of e to the power of ax and the inverse Laplace transform, L of e to the power of minus ax and the L of. I have applied all these things, and find that you come to a place where you have to necessarily go for splitting up the fractions using partial fractions. So we are applying partial fractions idea. I split it into small fractions like this. See, these are all small fractions. See here. Now only when you get down to this form, you can apply the Laplace, inverse Laplace transform. Otherwise, it will be difficult. So you see that I bring it to that form and then apply, and immediately I am able to get the answer. So this is all about this problem. I will do more problems in the coming days. Thank you.